Hi, what's up, teacher? Today, as always, think I've done it like 20 times. I'm gonna do this. I'm gonna present this physics project. Okay, all right. I put here the colegio mode and my name. Topics. Um, I'm gonna talk about the high buildings, the highest buildings in the world. Vectors and the international system of units. All right. I'm gonna start with the top 10 highest buildings. Well, I put the top five, and here's the formula: is the time required of two times the height and divided by the gravity. And in this case, it's 9.81 as in Earth on Earth. All right. Golden Finance is the top five, and this was the formula that I used. Um, it's like is this thing as it was 597 meters, I multiplied it per two, and then I've got this and I divided to this, and then in and then it equaled 121.7, that equals 11.03. So that means um when you throw something from the top of the building, it should um, it should um, it should be like 11 seconds. So that's a lot, right? And the Ping'an in China, 599 meters. So that means you have to divide by two, multiply by two, and divide by the gravity, and then you've got the 122.1. So that means so that means it it must be 11.04 seconds, right? Top three as well. It's kind of the top three. Abraham Lloyd. The format to calculate it as always. In Arabia, the 601 meters. As always, as we've done it so many times, as I've said it so many times, the same thing. And then you must towered 11.06 seconds. All right. Then the Shanghai Tower in China. This is the formula. So I've done it. We've done it so many times, and yes, when you throw something from the top of the building, it um shoot down 11.34 seconds. All right, and of course, the top one. Let's go. What do you think it is? I'm gonna get some hype. And the top one is Burj Khalifa. As you should know, everyone knows that. Knows this what. And well, um, yeah. I mean, we've done the same, and spent almost 30 seconds. Since if you throw it to the from the top, and it is 828 meters. So now one of my favorites, the International System of Units, or the SI. All right. What is it? Is a To summarize a bit, is a system of units that almost the whole world practice. So that this means um it is very famous, and it's you can like measure the lots of things like, and the measure things are like a meter, kilogram, second, ampere, Kelvin, mole, and candela, right? Let's start with the length of a meter that it comes with the length. Um, it's like the distance light that travels in a vacuum in one and divided by 209 that number seconds. And the other use of the word meter in science is as measuring device. For example, a water meter measures the amount of water that flows per unit of time. Then we forgot the kilogram mass, and the kilogram symbol is kg is SI unit of mass. It is defined by taking the fixed numerical value of the Planck constant h to be 6.623 and that numbers per um 1034 when expressed in the unit 1s, which is equal to kilograms and meter per second less 1. All right. And then one of the most famous ones, second is symbol s, is unit of time in the international system of units. Historically defined ones as that number of a day. One is one part of 86,400 of a day, right? This factor derived from the division of the day first into 24 hours. Then to go 60 minutes and finally 60 seconds each, 24 and per 60 per 60, that means that equals um the seconds in a day, right? Or 41 hours. Then the ampere made Laura, I don't like it, but I should mention an ampere is a unit of measures the rate of an electron flow or current in an electrical conductor. On 1 ampere of current represents 1 coulomb of an electrical charge. 6.24 times 1018 charge carriers, moving to past a specific point in 1 second. Then the Kelvin it measures the temperature. Um, it's based on basically on the absolute zero. It's the coldest possible measurement. It's like the centigrados, as I can mention, but Kelvin, right? Kelvin, Fahrenheit, and those things. All right. And the mole, it's pretty mid also. It's not very famous. Is the quantity of substance and an elementary entity which may be an atom, molecule, ion, electron, or any other particle or a specific group of such. And here the candela that measures the light, and well, the candela, and that is the as Greeks can as Greek says, that symbol is the unit of luminous intensity in the international system of units. It measures luminous power per unit slight angle emitted by a light source in a particular direction. And well, that was all from the international system of units. And now we're gonna go with a pretty interesting a pretty interesting a pretty interesting thing, which is the vectors. Right, vectors are objects in mathematics that have both magnitude, size or length, and direction. They are often represented by arrows, where the length of the arrow represents the magnitude. The direction of the arrow indicates the direction. We've done this, like we did this in a long time ago, but I think it's a very good exercise, and I like it. Right, but this bottle, when I opened and this bottle, and that's one that arrow represents that arrow represents and like the force that it went the that thing bottle, then chugging, I chugged and then the force when the arm pressed, and that the force went into my mate's neck, and then I slapped it. She slapped me, and well, that makes the also the force, alright. And then pushing up when my mate took the share or I am up. That means is it goes over, the force goes over. It's pretty easy, as you can see. Well, you know, but you explain us, but I should explain it, alright. Then pushing, if when you push someone, you put the force in their elbows, with elbows in their, yeah, and they go forward, alright. A pretty interesting example is this cycling, that when you pedal, you you're making force right down your shoe, and that's also a vector example, right? And pressing the paddle, it's pretty easy when you like press the paddle and goes like down, you know. This is my favorite shooting. When you shoot, when you shoot at the goal, um, you're making force on the on your feet when you with the ball, and then it goes literally there. Then a seven, and when you step literally, it's a picture of the sister of Rich James stepping on a black female, like a black player, and well, she's deaf on it, and because she's deaf, and that means um it the force went down, right. Now the most important part, the conclusion. What do I think about these projects and all things that you've done? I mean, I like them when we go like outside to play something. I like that thing, but I believe this project is pretty repetitive, right? We've done this like 20 times. I mean, at least I've done it 20 times. I can say 4 times um, in 4 times in, not 20, more like 10, or yeah, 4 times on physics in second grade, 4 times, so that means it's 8 on third grade, and now we're doing it again, and this is the third time, so that means we've done it 11 times the same thing. I mean, it's pretty boring, but I have to have a great note and a great grade, right? Well, that was all. I liked doing this presentation, and I hope you have a great day, and you see my presentation, and I've got a 10 on this, and 9, all right? Um, see you, teacher, and I hope you change. I'll be right this, but a better ones that I know you have a very high knowledge of it, of your very good physics, so I believe you can actually show us some other things, and to make different projects. And if you're gonna do this project, um, or you're gonna do a project that, as this year, you did this you make us did this project, then you make us and did another project. You have to do 2 projects. I mean, for me, it's that's a lot. And now the things, all the works and that things, we're always doing presentations, and I don't know. Well, I see you, teacher, and I hope you have a great day. All right.